Here we're trying to bring some meaning to this lesson called completing the square. So to complete the square for the expression x squared plus bx, we want to actually write this as a completed squared trinomial. So what we end up doing is taking that second coefficient and halving it and squaring it, and that becomes the last part of the trinomial. So this trinomial here then becomes this squared binomial. And the important thing to recognize too is that when we do that, we are needing to start off with the first coefficient being 1 in order for this to work. That'll become more meaningful in a little bit, but let's go ahead and start by just giving a demonstration here. So what if we started out with x plus 5 and squared that, and what if I squared that? Then it's just taking this guy right here, this binomial, and multiplying it by itself. Now when we do that, and if I do it quickly, I end up with the first term squared plus 2 times the two terms multiplied together, so 5x times 2 is 10x. And then the last part, 5 squared, which is 25. So this right here, this trinomial, is a perfect square trinomial. The reason why it's called a perfect square trinomial is that it is the result of multiplying a binomial by itself. So there that is. How do we do that if we wanted to complete the square on something that looks like this? How about x squared? I'll go ahead and use that 10x. And say minus 7. And I wanted to complete the square in order to rewrite this as a squared binomial and whatever's left over in order to make that work. Well, the thing I'm going to do is I'm going to actually move that negative 7 over, and I'm going to now do the trick of completing the square. That takes taking the 10, dividing it by 2, and squaring the result. Well, 10 over 2 is 5. 5 squared is 25. So there we have our completed square, just like what we had up here. And then I'm going to subtract 25 because I just changed things. And so I just unchanged things by subtracting the 25. So what this results in is this trinomial being able to be written like this. I take that 10 over 2 and put it right here, squared. And now I just add the negative 7 to the negative 25, and I get negative 32. So this right here is the same as what we started with, only now I'm rewriting it with a perfect squared term. So here we're going to do one where we actually have to factor out that first term. So let's start off with one that looks like this. 2x squared plus 12x minus 7. And we have to just factor out only from the first two terms that 2. So let's factor out the 2. 2 times x squared plus 6x. And I'm going to finish that off a little bit long because I want to leave myself some room to complete the square. But here is the negative 7. So really this is no different. But let's just keep on going. Now I'm going to look inside the parentheses and take that second coefficient, divide it by 2, and square that result. 6 over 2 is 3. 3 squared is 9. So I'm adding 9. But inside the parentheses, I'm going to subtract 9. And watch how that works. So this part right here is a perfect square trinomial. And it can be written this way. X plus 3 squared. I'm going to put minus 9 because there's that part that I wrote there. I'm going to still put these parentheses around everything and put the 2 outside and put minus 7. So I really still have equivalently an expression that is the same as what we started with. So now I have to redistribute that 2. 2 times x plus 3 squared minus 18 minus 7. And so now this whole thing, when I combine it right, looks like this. And here's our completed square. Minus 25. And so that is something useful for doing a completed square. Okay, here in example 3, we're going to be applying what we just learned, only this is a more difficult version of the problem, and you'll see why I say that. We have to start off by factoring out a 3 from the first two terms. So when I do that, I get 3 x squared minus, that turns that into 4/3 x. I'm going to finish that off wide, and I'm going to put the minus 5 outside. Now let's complete the square. We're going to take that second coefficient, which is now 4/3. We're going to half it, which is the same as multiplying by 1/2. And I end up with negative 2/3. And we square that, which becomes 4/9. That's what we're going to add. And that's what we're going to subtract. We just added a 0 by doing that. So that turns the first three terms inside the parentheses into a perfect square trinomial. And it can be written this way: x minus 2/3 squared minus 4/9. That's what's in the parentheses. It has to stay in parentheses because we have a 3 outside that has to be multiplied in. And that equals, and that's minus 5 equals 0. Now we can subtract, or we can add the 5 to both sides. We can also divide by 3 for that matter. And now we just have this: x minus 2/3 squared minus 4/9 is equal to 5/3. If I add 4/9 to both sides, and get a same denominator, I get 15 plus 4 over 9. So let's rewrite that up here. And 15 plus 4 is 19/9. We can take the square root of both sides. Since that's a number, I got to say plus or minus is the square root. And that turns into plus or minus the square root of 19/3. And the left side is now just x minus 2/3. So if I add 2/3 now, I get 2/3 plus or minus the square root of 19/3. That's the solution for x in exact form.